You lived a whole life before you turned 3, and you don't remember a single second of it. You learned to walk. You said your first word. You had a favorite face you lit up for, and a first taste of real fear and real joy, and all of it is just gone. Most people figure the reason's obvious. You were just too little. Your brain wasn't finished yet. Nothing in there to record with. But that's not it. Your brain was recording. Every single day of it. So where did all of it go? Here's what nobody tells you. That blank isn't a flaw in you. Scientists have chased this puzzle for more than a century. Freud even gave it a name back in 1905, infantile amnesia, though he was dead wrong about the cause. Every person who has ever lived is missing those exact same years. The years you learned the most are the ones you can't reach at all, and you're missing them for a reason. Forgetting the very start of your life might be one of the smartest things your brain has ever done. So over the next few minutes, I'll walk you through the 3 reasons those years vanished. First, the physical reason, what your brain was literally doing to itself before you could talk. Then the deeper one, the reason there was no you there yet to remember any of it, no self, no words, no story to keep. And finally, the strangest reason of all, the one scientists only cracked open in 2025. But before any of that, one sneaky little question. Those missing memories, were they ever really there in the first place? They were, and we can prove it with one of my favorite experiments in all of psychology. Starting in 1979, a researcher named Carolyn Rovey Collier tied a ribbon from a baby's ankle to a bright crib mobile hanging over her head. Baby kicks, the mobile dances, and the babies figured that out fast. Kick, and the world moves. Then she'd untie the ribbon, disappear for a few days, come back, hang the same mobile up, and just watch. And the babies kicked right away. They remembered exactly what to do. So yes, babies form memories. They hang on to them. A 2-month-old could keep that little trick for a couple of days. A 6-month-old, closer to 2 weeks. And if you slipped them one small reminder in between, they held on even longer. She later ran a version with older babies too, a tiny train they could set going themselves, and some of them remembered it for months, which completely wrecks the easy answer. Your baby brain could record just fine. The memories were there. They were right there, so they didn't fail to form. That was never the problem. The darker question is this: what happened to them? Start with the hardware. Deep in your brain, there's a little curl of tissue called the hippocampus. Its whole job is to take a passing moment and file it into a real, lasting memory you can pull back up later. It's basically the thing that turns right now into remember that time? In a baby, that machine is still half built. There's a tiny gatekeeper inside it called the dentate gyrus, and it doesn't even reach its grown-up shape until somewhere around 12 to 15 months. Then it keeps rewiring itself for years after that, and doesn't really settle into its finished form until you're 4 or 5. Now look at the timing on that. That's almost exactly when your first real memories start showing up. Not a coincidence. For most people who grew up in the West, the earliest thing you can dig up sits around age 3, maybe 3.5. And before age 2, there's basically nothing. So part of it is just that the filing system wasn't done being built. But that's only half the story, because the next piece is stranger than a half-built machine. It's the possibility that your brain was actively shredding its own files, on purpose. In 2014, 2 neuroscientists in Toronto, Sheena Jocelyn and Paul Franklin, published a study in the journal Science that flips your intuition completely upside down. A baby's brain isn't just growing, it's going off like fireworks. New neurons are getting born and wired in at a speed you will never hit again for the rest of your life. There's a name for that, neurogenesis. And here's the catch nobody sees coming. Every time you jam a brand new neuron into a circuit that already exists, it rewires the whole thing. You're dragging the furniture around a room where somebody was still trying to remember where they left things. So the 2 of them tested it head on. In young mice, they cranked neurogenesis up after a memory had already formed, and the memory faded away. Then they flipped it. They slowed neurogenesis down in baby mice, and the memories held on. The very same process that was building the brain was the one wiping it. Now, one honest heads up, because it really matters. This was mice. Whether the same thing wipes your human baby memories is a strong hunch, not a settled fact. But it changes the whole shape of the mystery. Your earliest memories might not be gone because your brain was too weak. They might be gone because your brain was too busy. It was tearing itself apart and rebuilding at full speed to make the person you were about to become. And even that is only part of it. Honestly, this next part might be the strangest of the whole bunch because it's got nothing to do with hardware. For something to be your memory, there has to be a you for it to happen to in the first place. Think about what a memory even is. It's, this happened to me. It needs a main character. And for the first year or so of your life, that character doesn't exist yet. You can actually watch it switch on. Back in 1979, two researchers, Lewis and Brooks Gunn, ran what's now the famous mirror test. They'd sneak a little dab of rouge onto a baby's nose, then sit them in front of a mirror. A young baby reaches for the reflection, like there's some other kid in the room. But somewhere between 18 months and 2 years old, it clicks. The kid reaches up and touches their own nose. They get it. That's me. And that first spark of that's me shows up almost exactly when your earliest memories begin. Before it, there's no narrator. Nobody sitting in the middle of the story saying I. And a story with nobody in it is really, really hard to hold on to. There's one more thing you didn't have yet. Words. And words matter way more than you'd think, because language does more than describe a memory. It gives the memory a shape to hold on to. Two psychologists, Catherine Nelson and Robin Fivish, showed that memory really takes off once a toddler can talk, especially once a parent starts doing that thing where they ask, "Remember when we went to the beach? What did we see there?" That's when it kicks in. The kid is learning to wrap a raw experience up into a story, with a beginning and a middle and an end. Something you can file away and pull back out later. Before you had words, your experiences were real and bright and completely yours, but they were like water with no cup. The feeling was the whole thing. There was just nothing to pour it into. And a memory you can't hold slips right through your fingers. But keep one question in your back pocket as we go, because it's about to swallow this whole story. What if these memories aren't actually gone? What if they're still in there, right now, and you've just lost the door back in? And maybe you're thinking, okay, fine, this is all just fixed biology. Everybody's memory clicks on at the same built-in moment. Here's the part that proves it doesn't. Your culture can move the date of your very first memory. Researchers like Chi Wang at Cornell and Harlene Haynes' team over in New Zealand found that the more a culture dwells on a kid's personal past, telling their little stories back to them again and again, the earlier that kid's memories start. In one New Zealand study, Maori adults, whose tradition puts huge weight on personal and family history, had earliest memories reaching all the way back to around 2.5 years old. Their New Zealand European neighbors? About 3.5. And in some East Asian groups, where the self is framed less around your own personal story, the first memory landed closer to 4, sometimes later. Same species, same brains, but the age your memory switches on slides around by years, depending on how much the people around you kept handing your own story back to you. So put it all together, because it was never one single thing. It was everything, all at once. A filing system that wasn't finished. A flood of new neurons, writing right over the files that were already there. There was no self yet to be the main character. No words to build the story out of. And nobody, yet, handing your story back to you. And when you stack all of that up, you land on a quietly unsettling thought. That little kid in your oldest photos, the specific one, with real memories, real fears, a favorite blanket, their brain got physically rewired, cell by cell, until it turned into yours. Not as some poetic metaphor. Physically, the wiring that held their memories got pulled apart and rebuilt into the wiring that holds yours right now. The self that could say I hadn't come online yet. and the memories they made got written over to make room for the ones you'd keep. So look at that photo one more time and actually ask it, is that baby you? Or is it somebody else? Somebody who lived in your body first and had to be quietly taken apart so that you could show up. For about 100 years, that's more or less where the story stopped. The memories are gone, written over, erased. And then, in 2025, that answer cracked wide open. At Yale, two scientists, Tristan Yates and Nick Turk Brown, pulled off something barely possible before. They slid awake babies into an MRI machine and scanned their brains while the babies looked at pictures. And they caught something nobody was expecting. When a baby's hippocampus lit up hard the first time it saw a picture, that baby was more likely to recognize that same picture later. In plain English, the baby brain wasn't failing to record at all. It was laying down actual specific memories, and it kicked in right around 12 months old, which throws the whole thing back open. Maybe your baby memories were never destroyed. Maybe the problem was never recording them. Maybe it's getting them back. Maybe they're still sitting in there, perfectly intact, and you've just lost the key to the room they're kept in. Now, easy does it here. This was 26 babies, measured by where they chose to look, not by anything they could actually say. The scientists themselves called the idea almost science fiction, but it takes the oldest answer in this entire field and turns it into an open, unsettled fight. Were your first memories wiped for good, or are they just locked away, somewhere inside you, forever? So where does all of this leave us? Every single person you have ever met is walking around with this same black hole where their beginning should be. And that blank is the cover charge, the price of everything that came after. Your brain didn't fail to save those years. It was busy doing something more important than saving them. It was becoming someone. And that meant taking apart the person who came first, cell by cell, rewiring their neurons, drowning out their world, until finally a self held together that could look back and call all of it me. You are never getting those years back. You can't remember the first face you ever loved, or the first time the world ever caught you off guard. But maybe, just maybe, that baby isn't really gone at all. Maybe they're still in there, behind a door you'll never quite find, quietly watching the whole thing from a room you can't open. If a question like this is your kind of weird, come hang out for a while. Subscribe to Oddly Human. We take one strange little truth about being a person and we follow it all the way down.